Great. So I am going to start with a video. Oh, great.
Rotor builds the most capable UAVs in the world. Meet the Air Truck, a heavy-lift unmanned helicopter that carries over 1,000 pounds of payload, more than any other commercial UAV. Built on a dependable full-size helicopter platform, Air Truck is designed for difficult missions in remote locations. A high-performance aviation engine delivers long flight times and heavy lifting power. And then there's Sprayhawk, a 110-gallon agricultural spray drone. Sprayhawk follows spray paths automatically and uses sensors to detect obstacles, making operations more efficient and keeping pilots safe. Every Rotor UAV is built at our factory in Nashua, New Hampshire in the USA. Our UAVs have been flying since 2022 and have earned numerous accolades for innovation. Rotor also provides proven autonomy technology and services to partners such as fleet operators and aircraft OEMs. We are Rotor. We build big drones for tough jobs.
You can outrun the devil, but you ain't gonna out.
Yeah, so what a great way to get here is one of the more constructive late-night LinkedIn activities that I've done. But a little bit about Rotor. So we're based in Nashua, New Hampshire. Originally, like Andy said, a team of MIT scientists, but now there are about 40 of us, including a number of pilots, aerospace industry veterans. So our mission is really about using technology to make helicopters unmanned and safer, particularly for difficult missions. I'm going to talk about agriculture particularly as one of the most promising use cases for the technology that we've built. We're a very open company. We're quite young, so really kind of trying to get the word out there and having people know about what we're doing. You're very welcome to come visit our R&D and production facilities in New Hampshire. It's about 50 minutes north of Boston Logan Airport. So our aircraft primarily are designed to be unmanned to serve dull, dirty, and dangerous missions. So that includes air application and agriculture, which I'm going to talk a lot about today. Utility survey, firefighting, and a lot of your maritime offshore logistics and specialty government roles. Our agricultural spray version is called the Sprayhawk. It's fully unmanned and based on the Robinson R-44 helicopter. It has 110-gallon capacity and 240 acres per hour, designed to cover that acreage. So we announced the product about a month ago. We recently received a special airworthiness certificate from the FAA for the spray version of the helicopter, and we're preparing it for flight. We're also very fortunate to have had a lot of attention and coverage in mainstream media, and we're hoping to spread the word in the agricultural community too. So a little bit about our approach. It's all about building automation on a reliable platform. As we've heard earlier today, the retrofit approach just allows you to get to market faster and build the things that really matter without trying to reinvent the wheel. So the Sprayhawk is built on the Robinson R-44 Raven II. It's actually an increasingly popular agricultural spray helicopter, and it's developed by Robinson Helicopter Company, who is a key development partner for us. What we build are the flight computers, GPS, actuators, and software that replace the pilot. So we strip out all of the pilot controls, the seats, the avionics, and replace it with our autonomous flight control system. We also load the aircraft full of sensors, including cameras and LiDARs, so that it can see in all sorts of visibility conditions and tackle some of the very challenging mission sets that require high situational awareness. We think one of the strongest value propositions beyond safety is lowering the cost of crop protection and area application. compared to many of the products, the existing legacy products like the R44, like the Air Tractor and the DJI, we can offer significantly lower direct operating costs without exposing pilots to dangerous environments. A lot of that comes from the fact that we don't have to carry a pilot on board, so there's significantly higher payload capacity than a stock Robertson R44. Here's kind of just going through some specifications for the folks that like to get into the details. We cost less than $1 million for the introductory model year in 2025. The max takeoff weight is 2,500 pounds. We're going to be the largest spray drone available, unmanned spray aircraft available when it enters service. It has a cruise speed similar to the Robertson R44, allowing it to spray very productively. One note is that, like many other unmanned aerial vehicles, it has to be operated within visual line of sight, which is about 5 miles or 8 kilometers. And we've made it very easy to load, unload, and transport the aircraft by road. The R44, for those of you who may know about it, is actually just about the biggest aircraft that you can transport on US roads without having to disassemble it. And we think that's a really important operational characteristic for our operators. It also has a very long endurance because it has a gas engine that burns aviation gasoline, which is widely available across the US also. I talked a little bit about loading it full of sensors. There's 5 cameras and 2 LiDARs on the aircraft that allows it to follow terrain automatically and avoid obstacles. We're also working on finding ways to effectively detect wires and birds, which we understand are some of the more challenging obstacles that face, dynamic obstacles that face operators in agriculture. We're also very heavily invested in communications technology, and so we think we have one of the most diverse and robust communications links between a ground control station and a remote pilot with the aircraft, which reduces many of the accidents that people are seeing with smaller drones today. So where are we in terms of development? We first flew our unmanned aircraft in late 2022. We've recently finished one and are about to complete the second production prototype, and we've recently received our FAA airworthiness certificate. We're now working with agricultural partners on an early release at the end of this year or early next year so that people can start getting Sprayhawks in their hands and flying them. We know it's off-season, but we'll still be able to demonstrate the flight profiles and the coverage area and the trailer landings that are very important to the customer set. And we hope to begin serial deliveries at the end of 2025 so that people can be familiar with them and be trained to operate them by the 2026 summer season. It's very much a crawl, walk, run approach, and we're heavily invested in our relationships and partnerships. And one of the reasons I'm here is so that I can meet you all and learn more about the industry. We do not have a vertically integrated business. We rely on technology partners, for example, AgNav, which is a key agricultural navigation provider, to integrate their algorithms into our flight control systems. We work with people who build booms, who build tanks, to find the best people who do these things today and integrate into our systems. So we're a very collaborative company. And that's similarly true in terms of our go-to-market. We're here to serve aerial applicators. We're not going to be providing aerial application services ourselves. We want to make the people that own Robinsons, that own Air Tractors, that own DJIs today even more successful, even safer in their operations. So I'm Hector. I'm here with my colleague Charlotte. We're here till about 3 p.m. before we have to head back to Boston. Please come visit in Boston. Please come talk to me. This is my cell phone number. This is my email. We're very easy to get hold of and very friendly. So I'd love to chat to you and hear about what your challenges are and how we can help you. Thank you very much.